So, hello everybody. I hope everyone is doing well. This is the first video of the machine learning series. I'm going to talk about machine learning and its capabilities in this course, almost. This course is mostly structured around machine learning and its capabilities, specifically the algorithms, the methods, some of the mathematical functions, and all the related content that are more technical side of machine learning. I am planning to do a few videos on this series to really help you understand what exactly is machine learning and how it is used in different cases. I am doing this for myself as well because, as you know, it's one of the best ways to learn something is to understand it to be able to teach other people or to be able to express or explain to different people. So we are, at the end, we are going to understand more about machine learning and some of the functions, some of the approaches that it includes in its field. Let's talk about the contents first and then start with the lecture. The first part, I'm going to talk about artificial intelligence, which is the term that we hear a lot on the media. And I'm going to address what exactly is artificial intelligence, and we are going to be able to separate the similar terms when it comes to smart systems or artificial intelligence systems. On the second part, I am planning to talk about machine learning, which is the main focus of this course. I'm going to answer some important questions to really help you understand why we are working on machine learning and why we are learning about it. And then I'm going to give you one of the simplest representations of a machine learning system. This will help you get a first look on a machine learning system that doesn't require a lot of knowledge. And at the end, I'm going to give you some example applications that we see or use in the real world, specifically specifically on different industries. And this will help you somewhat get an idea of how machine learning is used in the real world applications and technologies. And if you're ready, let's get started with the artificial intelligence. So the first question we need to understand, or the first question we need to answer, is what exactly is artificial intelligence? What is this term? What is this concept that we hear a lot on the media? One of the basic representations could be artificial intelligence is a technology that enables machines to mimic human-like thinking and decision making. So there is a technology we have that enables machines to mimic humans, us, our characteristics, our thinking abilities, our decision-making abilities. And one of the important part here is the mimicking part. What it means is it just mimics it. So it's not a sentient being. It just uses a lot of information that is gathered from humans to act like us, to make decisions and think similar to us, but it's not the same. So it does not have brain by its own. It does not think by its own. So don't get fooled by AI models. And then another representation more towards technical side could be a method to use data and algorithms to perform tasks. Here we have a lot of data, right? In this age, we have a lot of data, a lot of digitalization in our world. So there are a lot of data from a lot of different kind of sensors. Artificial intelligence leverages this amount of data and some specific algorithms, mostly focused around mathematics and statistics and probability, specifically linear algebra in mathematics side, to perform some of the tasks that we define. Here, data is any information that can be represented or defined with numbers. So if you can define or represent any information out there with a set of numbers, that you can use that information as data and to create a machine learning model and leverage it. So this is pretty important in this case. Data is one of the most significant part of a machine learning or artificial intelligence system. So right now you have a basic idea of what is artificial intelligence, but we hear different terms when it comes to intelligent systems. When we think about these, we can define artificial intelligence or represent or visualize artificial intelligence and related content in this blue circle. And when we do some research on the internet, we hear another term that is used, which is machine learning, and one of the main focuses on this video series. Machine learning is actually a toolbox that includes all the algorithms, all the mathematical functions, all the approaches that enables you to create an artificial intelligence system. And as you know, in the last few years, specifically last few months, there is another term that people are excited about, which is deep learning. Deep learning is one of the most complicated part of artificial intelligence because it requires you to know a lot of mathematics and a lot of probability and a lot of functionalities of computer and programming. Deep learning is, in the simplest terms, kinda similar to our brain. It has a deep structure that leverages perceptron, which is an object that inspired by our neurons in our brains. I'm not going to talk about deep learning too much in this series because our main focus is machine learning, and deep learning alone needs another video series by its own because it's complex and it's pretty important. So let's get to the second part. We know some of the basic terms, and as you know, we defined artificial intelligence with two different definitions. But what is machine learning? Before giving you any definition, when you think and visualize something just by its name, you can tell that it's a machine that is able to learn, and it's quite correct. One of the best definitions we can make is machine learning is a branch of AI that enables a computing unit to learn without being explicitly programmed. Usually, in traditional programming, we program everything by our own. We need to specify everything. We need to be very specific, and we shouldn't miss any possibilities in a software. If we do, there is a lot of unexpected events going to happen. But in machine learning, you do not need to explicitly program the system. You can use the power of machine learning algorithms to kind of work by itself and figure the problem by itself. The computing unit here is any hardware that has a CPU. So it needs to have some sort of ability to decide or process information. Another definition is maybe much easier to understand, is the science of programming computers so they can learn from data. So machine learning is fundamentally science of programming computers so they can learn from data. Learning here is not the same as how we do it. We learn differently than computers. When we define learning, it's the ability to solve any problem from the similar past experiences. So in order for a computer to learn something, it needs to have similar past experiences correlated with the problem at hand. I hope you understand more about machine learning now, and I know that some of the definitions are hard to understand, but if you like to do it, you can rewatch it again and try to think by your own and come up with other definitions and maybe search about it. Right now, we are trying to learn machine learning, but why we should learn machine learning? There are a lot of approaches that we can take. So in what situations, in what type of problems it is good to use machine learning for? So machine learning is usually good for problems which requires a lot of fine-tuning. Fine-tuning here means small adjustments for better adaptation to specific tasks. In some occasions, programmers need to do a lot of fine tuning in a system. They need to change a lot of parameters, different approaches, and they need to iterate over the combination of those. And it's not really time efficient. In these cases, machine learning is pretty helpful because it can fine-tune itself in every iteration. You still need to do some iteration, but you don't need to specifically think in much detail as you do in the previous approach. Machine learning is good for problems which require long list of rules. So in a lot of cases, actually, you need to think about a lot of events and a lot of cases. Sometimes there are a lot of possible events and cases and conditions that might occur on runtime. In order to do when there is a lot of events and cases or conditions, even though you write everything down carefully, it's prone to errors. You might miss some of the cases and conditions, and this causes unexpected results, and this is not what we want. So in these type of problems, machine learning could help generalize the problem, and you specifically don't need to think about all the possibilities that will happen in the program. Machine learning is really good for generalizing, and if you create a successful system, it will do it almost perfectly. Another type of problem which machine learning is really good to use for are complex problems. So complexity could be in different forms. Complexity could be caused by dimensionality or data complexity, scale, or technical knowledge. So what do I mean by these? Sometimes some of the problems have a lot of dimensions included. Sometimes what you want to do is not that basic. It requires you to think in different dimensions almost. It's hard to explain this, but think about layers. Sometimes your program consists of a lot of layers, and in these type of problems, machine learning is really good to use for. Data complexity is another cause of complexity. Sometimes you have really messy data, really bad data, and this will cause you to work on it too much and maybe lose a lot of time and effort. And this is one of the complexities that you can use machine learning to kind of resolve the problem. In some occasions, your problem is pretty big scaled. There is a lot to think about, a lot to solve, and you might miss some of the key points on the problem, and this might cause a lot of inconsistencies in your program. In these type of problems, it's good to use machine learning because, as I said, it is good at generalizing. And lastly, some problems require you to know some specific technical knowledge to be able to solve successfully. And maybe you don't have enough time to really spend your time to learn this technical knowledge. And even in some cases, you really need to be expert at the problem to be able to solve efficiently. In these type of problems, machine learning generalizes to the problem and kind of saves you a lot of time and a lot of effort of knowing the specific technical knowledge required. So let's get to the interesting part of the video. What you see here is simplest representation of a machine learning system. As you can see, it consists of three main components. The first one, the left one, is being the data. The middle one is named model, and the last one is being the output. And as you can see, there are operations between the components, and I'm going to explain to you these components in a small detail. But look at it for a little time. Look at it for a bit. Let's talk about data. It's presumably one of the most important components in our system. If you don't have a good data which is representative, high quality, and enough data, it's not possible for you to create a successful machine learning system. So data is one of the keys that will enable you to create possibly a successful machine learning system. So data could be anything. It could be an image or a video. It could be a text file. It could consist of numbers, and it can be a container that has a lot of numbers stored, which we call vector or matrices. So it could have dimensions, and it can be a sound file. As you know, sound file includes a sequence, so it could have a sequence information inside. The second component we have is the model, which is the heart of our system, which is the component that decides everything. And in the simplest representation, model is basically a mathematical and a statistical function. And as you know, functions have an input and an output which is related to an input. So because of it, it has an input and output relationship. We can, in practice, represent a machine learning model as a function. But as you know, when we think about functions, we think pretty simply and basic. We don't think like complex functions. But in case of machine learning, these machine learning models are pretty high ordered, which means they have lots of parameters. This could be 100, this could be 200, 1,000, 100,000, million, billion of parameters. So it gets quite complex quite quickly. And as you remember, there are some operations that are visualized between the components. What are these operations? In real life, we don't have data that represents our problem. We need to do a lot of operations on the data to really leverage the data we have. There are few example operations that are listed here. The first one is data preparation. As it's pretty self-explanatory, we prepare our data before feeding it to the model. Data augmentation means increasing the amount of data we have synthetically. I'm not gonna give any more information because it will probably get complex. And lastly, feature engineering, meaning in data we have a lot of features that represents the data. Think about it as your characteristics as a person. Maybe you wear glasses, maybe you are at some age, your height, or maybe your weight. These are your features. In data, it's pretty similar to us. It has its own features that kind of characterizes or explains itself. In a lot of cases, actually, we need to do feature engineering, which means we need to transform these features into a different ones or create new features from the combinations of already existing features, and maybe we need to get rid of some of the existing features to be able to create a successful system. And lastly, we have our component named output. I represent it as a key because it is going to be a key for our solution. And as you know, I talked about machine learning model component in before, and I told you that it's simply a function. If machine learning model is a function, then output we have is a form of a data. Again, because it's a data, it could be in different forms. It could be in numbers. Again, it could be a probability. Probability will be between 0 and 1, which means you can decide if the probability is high. It kinda decides, but it's not really sure. It's almost like a percentage of how sure the model is. And again, it could be a container for numbers, which in this case is vector or matrices, and it can be a text or message. The well-known example could be the chatbots that we are using right now, such as ChatGPT or Gemini. And it can only represent two possible outputs, like 0 and 1. It could be a binary, and these can be different things, like yes or no, or okay or not okay, or maybe, right or wrong, and etc. These are the type of examples that we can get as an output. And right now you know a good chunk of information about what machine learning really is, but it's going to be beneficial for us to know some of the example applications that we see in the real world. So at first we have analyzing images of products on a production line to classify them automatically. When you have a production line and you want to maybe tell if a product is okay or not okay, maybe you want to separate the products that have some sort of dysfunctionality or a problem with it. You can classify these products with a machine learning model and separate them automatically. This is called image classification, and it's pretty self-explanatory. You take pictures of the data you have in this case is images, and you classify them with a machine learning model and tell if image is, you can separate images into number of classes you define. The second example is detecting tumors or diseases. As you know, detecting diseases or understanding what disease someone have at early stage is pretty critical for doctors. In healthcare industry, you can leverage machine learning and its functionalities to detect these type of diseases, specifically tumors, at an early stage. This task is called image segmentation, which means segmenting a part of an image and labeling it. It's a bit different than image classification because you don't classify the whole image, you just segment a part of it. You classify a part of an image. Another example could be creating chatbots or assistants for companies. In a lot of companies, they have a lot of chatbots in their websites. You can talk with these chatbots to learn about some of the some of the services they provide. This saves you a lot of time because you don't need to specifically call for a person and talk to them and learn from them. You can always reach out to these chatbots and learn a few things from them. And this task is called natural language processing, in short NLP, and is pretty popular in the last few years because of strong chatbots that are created by big companies such as ChatGPT or Bard and etc. Another quite unique example could be making voice activated apps, which is under the task of speech recognition. Maybe you want a home security system that's just going to lock the doors if it doesn't recognize the voice. You can create this type of a system with the help of a machine learning model, and you can teach your voice to the machine learning model. In this case, your data is a sound file of your voice. Another popular example could be integrating recommendation systems to social media platforms, which is under the name of clustering. As you know, when you click on a video on a social media or like some content, maybe comments down on a content, you get similar recommendations based on your previous actions. This is possible because of the machine learning model or AI or intelligent system integrated into the platform. This task is called clustering. What it does is it clusters a lot of data points, and it clusters based on similar features, and it kind of creates colonies of data points almost. I'm not going to talk about this in detail because it's going to get complex quite quickly. Just know that it clusters data points together and groups them and labels them based on their similar features. And one of the most interesting use cases of AI or machine learning is building a bot to play in a game, and this is under the name of reinforcement learning, and in my opinion is one of the most interesting field of machine learning integration. Reinforcement learning enables you to create a bot or agent named agent that you provide information about an environment that you define, and it will gradually learn how to act on the environment and how to complete the tasks that you're given to the agent. It's pretty similar to evolving. Think about it as like something that is born and you kind of watch it to evolve with every iteration and every generation. So this is the end of the first video. It might be a lot to take. If you want to, you can always go back to it and watch some of the stuff again. And I appreciate it if you watch till the end. If you enjoyed it, you can always comment them below some of the suggestions you have. I will be happy to read all of them. Thank you for your time, and I appreciate your support. I appreciate your kindness. Take care and goodbye.